In this episode, we will be implementing a note or diary system into our immersive horror game. We will talk about creating notes in an image editor of your choice, as well as implementing a simple pickup system that you see in games like Slenderman. We will then expand on that system such that the note will go into the player's left hand and they can walk around with it. We will make the note tilt and sway based on the player and their camera movement. Finally, we will add a black overlay to the right side of your screen and allow you to write the contents of the note in that space. This will allow you to build lore for your horror game. Welcome back to the channel. We are going to start with a basic implementation of a note or diary system. It's essentially going to work like that of the Slenderman games, where you just grab a note and it disappears from the environment. Games like Slender just tell you that you have X amount of pages collected. We're not going to do that. We are going to improve on this system, but to improve, we have to start somewhere. Before we hop into Godot, I just wanted to briefly talk about how I created the notes that you saw in the intro and see now. So, a great resource for game development is a website called Open Game Art, and on that website, I found this texture called oldpage.png. I'll leave a link in the description below. And then I used two fonts. The scribbled one is called Help Me, and the typewriter one is called Special Elite. And I just used these two to type or write right on top of the page in my image editing software, which I use Paint.net. This obviously also works in GIMP or Photoshop. In case of the run note, I added a red handprint that I just found on Google Images and added an overlay to make it look a little more grizzled. I'm by no means an expert in terms of photo editing, so let me know if this is good, let me know if this is bad in a comment down below, but it doesn't really matter because we just need notes to implement for our horror game. So back here in Godot, all I've done is reopened our sanity scene. I've created a new folder in our assets directory. I've called it notes, and I've just imported our two PNGs, just dragged them right into the file system. And now we can talk about setting up our notes. So to set up our notes, we're just going to create a new scene. We're going to create another node. This is going to be a static body 3D. We're going to go ahead and recreate this run note, so I'll call it run note. Our static body needs two nodes. It needs our mesh instance 3D, and it also needs our collision shape 3D. Let's start with the mesh instance. The mesh instance is going to be a plain mesh. It is going to get a new standard material in its surface material override, and we are just going to go ahead and drag our run.png on it. And you can see it shows up. There are a couple problems. You can see that on the outside of it, it is covering its background with black. Let me go ahead and zoom in. You'll see that it should be brown like this because we want to see what is behind the note. This is better explained in Paint.net. What it's actually doing is painting the background black like that. We don't want that. We don't want to see a black edge. We want it to appear as a note would. So let's go ahead and fix that. It's very simple to fix that in Godot. Just open your material, open your transparency tab, and set it to alpha. So as you can see now, there is no black background. We are transparent. The second problem we see is that the plane mesh is a square, but our note is more rectangular. So our aspect ratio is actually incorrect. So we're going to fix that by going down into our transform and make sure that your scale is unlocked. If you double click your PNG texture, you'll see that you have the width and the height. So this is 1112 pixels wide by 1536 pixels tall. And we're going to use that to set the aspect ratio correctly. So down here in the scale, I'm going to do 1.112 to represent 1112. And then in the z-axis, I'm going to do 1536. And that looks like the correct aspect ratio for our note. Now, the reason we did it in the X and the Z is because this is in 3D space where X is left and right and Z is up and down, or I guess I should say Z is forward and back and Y is up and down. And because this is a note, we don't need any 3D geometry on it, so that can stay at 1. So let's go ahead and grab our collision shape. We are going to create a new box shape. So as you can see, this box shape is a little too thick for our note, and it also doesn't cover our note. Now this step you don't have to follow along with. I'm just going to make this for the sake of the tutorial. I'm going to change this albedo to black. So if you select your collision shape, you'll see these little red dots. And you can easily set these by going into your gizmo in the top right of your screen and clicking Y. So now you have a top-down view of your note. And you can just adjust the box shape so that way it covers the entire note like that. I'm going to make these some nice round numbers. I'm going to do 2.25 on the X, and then I'm going to do just 3, maybe 3.1. You do want to give it a little space, so that way your player can easily grab these. So if I come out of top-down view, you'll see that this box is much too big for this note. So I'm going to put this Y value down to something like 0.3. Now, once again, there's a lot of give here, but you really want your player to be able to easily grab notes. You don't want them to have to like squat and like tinker with their mouse to get it correct. And of course, you did not turn this black, but I need to reset my albedo. So now we have a note with collision, and it looks like a good note. And of course, it would not be one of my tutorials if we did not add our interaction component onto our run note static body. So go ahead and go to your interaction component, assign the object reference to the static body, and we need to set the interaction type to item. Now we will create a new interaction type later in the video specifically for notes or diaries or whatever you want to call them. But for this simple implementation to match a game like Slender, an item is fine because an item picks up and it disappears. And we don't need rotation, pivot pointer, nodes to effect in this tutorial. So go ahead and save this. Save it under objects and save it as run_note.scene. Now we just need to go back to our sanity environment and go to our objects folder and drag in our run note. So you'll see that the run note is actually very big. Now we don't need the note to be this big. We want it smaller. We want it looking like it came out of somebody's notebook. So let's go ahead and undo that, delete the run note from the scene and go back to its own scene here and click on the static body. Go to its transform and make sure its scale is 0.25 in all of them. So that way it's 1/4 of the size, and drag the note back in. So now if you look, the note is roughly the size of what it should be. So let's go ahead and put this on a wall somewhere. Maybe there, spin it around, turn it up, something like this. Pull it up, just put it on a wall like that. Maybe it needs to come forward, like that. That's pretty spooky, right? So let's go ahead and test and see if we can pick the note up. Running the game, I come over, I can see the note, it's on the wall. You can see that the reticle changes when I can pick it up. I click on it, it disappears, and you'll see that we have player collected run note. So if you see here, we have our on item collected, print the player collected the item, and as you can see, the player collected the run note. So if you were just doing a game like Slender, all you would need to do is add in some kind of line here to keep track of how many notes the player has collected. And there's your basic note diary system. Hey everybody, before we get too far into this tutorial series, I just want to remind you that this entire project is on my GitHub page. Feel free to pull it down. I just want to remind you of this because we will be changing a lot of little settings in our inspector, especially when we start discussing our Subviewport container. Now it is possible to miss these little settings and that can be frustrating to debug. So if you get stuck, just check out the GitHub page and see if you can find any differences. And since I have all of your attention, I'm just going to point out that 94.7% of you are not subscribed to me. I do make tutorials. I try to release one every 2 weeks. It would be a great help to me and my channel if you guys could subscribe and leave a comment just to boost my algorithm a little bit more. And for the sake of time, I also went ahead and added the text note. It's literally the exact same process, so I'm not going to go over it again, but we now have both of our notes. Now, we're making an immersive horror controller, and frankly, Slender and its 8 pages are some of the least immersive things in horror, so how are we going to improve on this? The first thing we're going to do is we're going to make it so that the player can actually pick the note up and put it in their hand. So to set up the player holding a note in their hand, go to your player scene, and you can see we have our head, our eyes, our camera 3D, and all of this is set up to work with our Subviewport with our light. Now, we are going to be adding another Subviewport, but once again, let's start with the most basic implementation. So click on your player's eyes. Now, if you'll notice, we have our hand here. If you remember, the point of our hand was if we grab a box, it'll be pulled towards the hand, right? So the hand is kind of a reference of where something should go. So essentially, we're just going to create another hand that is going to put the note in the bottom left-hand corner of the screen. So on your player's eyes, just hit Control-A and add another marker 3D. Just go ahead and rename this to Note Hand and access it as a unique name because we will be using this in code later. Now, we just want to position the hand so it's in this bottom left hand. corner of your player camera, and this kind of takes some finagling, and it's a lot of personal opinion on what looks good or not. But I think I'm just going to make them some nice round numbers. Minus 0.75, minus 0.25, and minus 0.75 seem good to me. Now, let's go ahead and just drag one of our notes up here, so that way it sits on it. Now, we're going to need to rotate it 90 degrees, because we want to be looking at the front of it, and maybe turn it 15 degrees or so. So now if we go into our camera 3D and hit preview, you can see the notes right there. So if you wanted to adjust this, you could do it from this view. So if you wanted the note lower, higher, kind of further away, you could do things like that if you wanted it nice and small. I like it big. I mean, it says run on it. It's got to be scary, and it's got to be in the player's face, right? So let's go ahead and run the game. And you'll see that the note reacts to light. So if I come over here in the dark, it'll go in the dark. Now, what we need to do is we need to have this have no note in the hand, and then when we click on the note from the wall will go to the note in the hand. That's a bit more complicated, and we'll get to it in a second. However, the problem we need to fix right now is that this note is going to clip into walls like that, right? Because if you imagine, this exists as an object on the player. So when the player moves their camera, we're moving a true object. And the way we're going to fix this is with a Subviewport. Now, if you just watched the Sanity tutorial, you know we are at least slightly familiar with Subviewports. However, we are going to be doing a little bit different because we need more than the light data, and we need this to appear on screen. So it's going to be a little more complicated, but I promise you I'm going to walk you through all of the steps. So the first thing you need to do is click on your eyes, hit Control A, and add a Subviewport container. The only thing you need to do is turn it to stretch, come up here to the anchor and offset values, and set it to the full screen. Now, this is a Subviewport container, which means that we need a Subviewport. So let's go ahead and save that, go back into 3D. Now, once again, a Subviewport is essentially like another game window, and it behaves differently. But I want to go ahead and point out something here. So if you look at our camera 3D, you can see a preview of the viewport of the game, right? So we can see the run note, and we can see the background, right? We see the dirt and then the sky, I guess, if you will. If you come to the Subviewport, it sees nothing, and that's because it doesn't have a camera. So if we add a camera 3D and we call this note camera, just like that, you'll see that these will see essentially the same thing. Well, we actually need to drag this up and set its FOV to be the same, because we essentially want two overlapping cameras right here. So if I switch between these two cameras and you look over here at this inspector, you'll see they see pretty much the same thing. But we don't want that. We want the player camera to see everything except the note in our hand. And we want the note camera to see the note but nothing else. Well, the first thing we need to do is we need to move the note hand marker onto the player camera, so that way it is a child of the player camera. And if I flip back and forth, that didn't do anything immediately because these two cameras still see both of them. So since they see the same thing, we need to modify the call mask and the layers. So let's go ahead and go to our run note, and let's go to its mesh instance 3D. If we look at its layers, you'll see that it will appear on layer 1, but not layer 2. So layer 1 is the player camera that sees everything in the environment. We want to set this to layer 2 and turn off layer 1, because we only want the note camera to see it, not the player camera. If we go back to the player, click on the note camera, we want the note camera to see everything on layer 2, but nothing else in the game. Remember, this note camera only exists for the sake of notes. Now, if we go to the player camera, we don't want the player camera to see on layer 20. That's our light detection. And now we also don't want it to see on layer 2. So now, if I swap back and forth between these two images, you'll see that the player camera doesn't see it, but the note camera does. However, there is still one problem. You'll see that they both see the exact same background, which is not what we want. The note camera should not see any kind of background. And the way we fix that is very easy. If you go to your Subviewport and just click on transparent background, you'll now see this checkered pattern, which means that it's not going to render anything except the note. So now if you flip back and forth between the Subviewport and the camera 3D, you can see that we have the image of the note, and then we have an image of the world. So essentially, we are going to be overlaying this image onto this one, but of course, only the note is going to override it. So I know that was probably a little confusing, but let's go ahead and run the game and see what we see. So the note is on the ground there, and it's not moving, and I have collision, and I can pick it up, but I'm not going to. The note in my hand is completely black, meaning that we're not getting any lighting data, and we can see the two notes over there. Now you'll notice if I left click on this note, it gets rid of the one in my hand. If I come over here, I can still pick these ones up. So what was all that about? That was pretty confusing, right? So the first problem we're going to run into is that lights by default only show layer 1. So we need to enable the light for layer 2. So you go ahead and save that and run it. And now you'll see that run is now affected by the lighting data in our game. But if you notice, I go into the dark and it doesn't change. And if I pick this node up, the other one disappears. I think it's pretty clear that the problem is this node on the ground is the one I'm actually seeing in my hand. The problem is that when I move my player, the run node is not moving with my player. And this is the same problem we had in the light detection area, where the light detection cube was not following the player. Now, I've since learned there's actually a very useful node to handle this, so that way we don't have to update it in code. So what do we need to happen here? We need the camera 3D and the note camera to be the exact same position and rotation at every point in the game. Go to your camera 3D, your player camera, hit Control A, and add a remote transform 3D. And if you read, it says this pushes its own transform 3D to another 3D. So if we hit create, essentially what this is going to say is this node is going to take the camera 3D's transform data, the position, rotation, and scale, and apply it to whatever node we assign here. And we are going to assign that to our note camera. So that way, these two cameras should always be in sync at all times. So if I run the game, you can now see that we have our run note. It is affected by the lighting data in the scene. We have our other notes here. This looks pretty good. So now we just need to figure out how to be able to grab a note and have it replace the one in our hand, or have our hand be completely empty, and then have a note appear. So let's talk about how we're going to do that. So now we get to go back to our interaction component script because we need to add a new interaction type. And I'm going to call this one our note. And then let's go down to our signal. So we don't want this to be an item because we want to be able to hold it. So we're going to create a signal and we are going to call this note collected. This is going to take in a node 3D. And now we need to come down to the very bottom of our script and we need to write our collect note signal. So let's go ahead and create a func, call it underscore collect note. This is going to be void and we need to do some logic here. So let's go ahead and type return and talk about it. So if I run the game right now, you'll see that if I look down, my player gets pushed around the screen. So what's actually happening here is that this note in my hand, where's the player? Give me head, run note. This note has a collision shape here. So we need this collision shape for our initial grab. We need our raycast to hit something. However, once we collect this, we need the collision shape to be deleted, right? Because we don't want our collision shape to collide with anything or to hit into the player. So let's go ahead and get rid of the run note in our hand in here. So if I run the game, you'll see that this is not a bug with the notes of any kind. Let's go into our script. And the first thing we need to do is we need to create a variable. And I'm going to type COL because that's our collider. We're going to call getParent because if you remember, this run note, we are writing in our interaction component. So if we get our parent, we're getting our run note static 3D. And then we're going to call find child, and the child we're trying to find is our collision shape 3D, We want it recursive, and we don't care if it's owned or not. So what are we saying here? We want to get the collision shape, so we're calling get run note and find its child that's a collision shape 3D. There are a few caveats. If you have more than one collision shape, you need to collect all of them. But since this is just a note, it should probably just have a box collision shape. So once we have our collision, we need to make sure that it's not null. So check that. What we need to do is we, once again, need to get its parent. We need to remove its child collider. So we don't want to call queue-free on this right away because that's going to cause us some bugs. We need to remove it from being a child of run note and have it just exist in the game. Then we can call queue-free. And that just makes sure that it doesn't mess up anything with the static body. So now that we have removed the collision shape, we're going to go ahead and emit signal, and we're going to call it note collected to mimic our item collected symbol. And what are we going to tell it that we grabbed? We are going to send it the static body 3D. So we're going to say get parent. Now, when are we going to call collect note? Well, we don't need any kind of pre-interact or post-interact or any kind of check going on for our note. We simply just want to click on it. And so the simplest way to implement that is in our interact, create a new interaction type. It is our note, and we are going to call the function we just wrote, which is collect note. So now we click on it, it should call collect note. It'll come down here. It will delete the collider to make sure we don't get any bugs when it enters our hand. And then it'll be emitted and told to our interaction controller that we have just picked up the note. So go ahead and open up your interaction controller and scroll up here. So remember, we did a very similar thing when we implemented the item here. What we needed to do is make sure that we're interacting with an item type. And if we did, we connected the signal. So we're going to do the exact same check. We're going to see if our interaction type is a note. And if it is, we want to collect or connect our signals. So we're going to connect note collected with our on note collected or on note collected signal. So if you're confused where on note collected and note collected come from, we are going to write a function in the interaction controller called on note collected here in a second. This note collected is the name of the signal we wrote at the top of our interaction component. So let's go ahead and go down to the bottom of our interaction controller script, and we're going to, let's do it right here by our on item collected. So we'll go ahead and create that function on note collected. It's going to take in a node 3D called note. We can say that this is void. And let's talk about what we need to do. So if you remember back at the earlier part of this episode, we are essentially doing what we did manually here. We need to add a note under the note hand. We need to rotate it and position it correctly so that way it appears on camera. And we need to make sure that it disappears from the environment and it becomes a child of the note hand. So if we go into our script, the first thing that we need to do, we need to get a reference to our note hand. So go ahead and make sure the note hand is accessed as a unique name. Hit Control and drag it in. So now we have access to our note hand here. What we need to do down here is we need to get the note. We need to get the parent. And we need to remove child. And we need to remove the note. So remember, this note here represents the static body 3D. So the static body 3D in somewhere in the environment, so let's take this text note for example, is going to be parented to either the world root node or maybe to this podium or something. So we need to separate this note from whatever it's attached to in the world so it is just a note of its own accord. So once it no longer has a parent, we can now essentially reparent it to our note hand. So we call our note hand. We are going to add child, and we want to make sure that the note, the run note, the static body, is now a child of our note hand. This, however, does not automatically reposition the note in 3D space. So what we need to say is our note transform.origin, note.transform.origin is now equal to our note hand note.transform.origin. So if you picture this in 3D, what we're essentially doing, the player has clicked on the note, we are pulling it so it is now attached to the player's note hand right there. So while the transform.origin may be correct, if the mesh was adjusted at any point during the editing process and it's wrong, we want to reset that. Now this is probably not necessary in most cases. However, we do want to make sure that our position is set to 0.0.0. So why is this? So if you think of our player, we only want the position of the note to be affected by the note hand. So while we reset its transform origin, it may still have position data attached to it. We don't want that. We only care about the note hand for its position, and then we will actually rotate the note itself. So now that we know it's at 0.0.0 on the note hand because we just reparented it, we now want to set its rotation. And if you remember, I told you to remember what rotation degrees you liked. For me, I believe it was 90, 10, and 0. And this is a vector 3. Oops, sorry. Vector 3. And once again, all this is doing is essentially changing our note rotation while it's attached to our note hand, so that way our player camera or our note camera can see it. So we can probably test this, but one thing we need to remember is we set up our run note interaction component to be an item. We need it to be a note now, and I'm going to do the same for our text note. So that way they will use the behavior we just created. So let's go ahead and run the game and see what happens. So I'll come up, where are my notes? I'll come up to my run note, I'll click it, and now you can see the note disappears and it is now reparented to my player. I can come over here and I can see this note and I can click on it, and you'll see that we now have two notes. But they're kind of Z-clipping. And the reason for that is we did not get rid of the first run note when we collected it. So we still have a little bit more work to do. The way we're going to do that is in our interaction controller. We don't actually have this set up yet, but we want to create our input function. So go ahead and create your input function, and we just want to check if our event.isActionPressed, and we want this to be our primary. So if we left clicked, what we want to do is we want to get rid of the note. So we want to get the children of the note hand, and this will return everything that is a child of the note hand, because remember what we're doing down here is we're reparenting the note to the note hand. And all we want to do is iterate for all those children. We've now seen the note and we want to click away. We want to say queue free, so we want to delete it. So if we go ahead and run this, I can click on the note, click off again, click on the note, click off again. And obviously this also means that if I'm holding this note, click this note, you'll see that they now both work. All right, so at this point we now have a note in our note hand. It is reactive to the environment, so light has an effect on it. We are able to get rid of it and pick up a new note. Same old, same old. However, this still just doesn't feel quite as immersive as I think it could, because it just kind of floats there. And if I move to the left, move to the right, move my head, nothing really changes. So we actually want this note to have a slight tilt and sway when you kind of strafe back and forth. It just makes the note feel a little bit more alive. And the way we're going to do this is we are going to do it in our player script. So go to your player script, go up to the top, because the first thing we need access to is our note hand. So now that we have access to our note hand, we're going to come down to the bottom of our script and we are going to write a new function. I'm going to go ahead and call this func note tilt and sway. This is going to take in two arguments. It's going to take in a input direction that is a vector 2, and then it's also going to take in delta, which is a float. So essentially what we need to know is, one, delta, which is the time between frames, because we are going to be lerping the note back and forth so that way it's swaying. And we need to know the input direction. Now, if you've been around since the very start of the tutorial, you'll know that we created our input direction up here in our physics process. So our input direction just represents whether or not the player is moving forward, backward, left, or right. And we're actually going to go ahead and call this method every single frame that the player is moving, so that way the note updates with it. So after move and slide, go ahead and just call note, tilt, and sway. And you just want to send in the input direction, and you want to send in delta. So if we come down here, we now need to write the logic for our function. So the big thing we need to check to make sure that we have our note hand. This should never be null. However, if for some reason we make a mistake and we delete the note hand, we don't want to crash. Now we're going to do two things. The first thing we're going to do is we are going to move the note to the left or the right if the player strafes to the left or the right. And then we want the note to kind of either push forward or backward just a little bit, depending on if the player is moving forward or backward. So we actually need to define two variables. So let's go ahead and go up to the top and let's create a new section of variables. We are going to call these our, note sway variables. And we need to have a var, let's call this note sway amount. This is going to be a float value. And we're going to set this value equal to 0.1. That way we can kind of tinker with it. So come down here. Now we've done linear interpolation a few times, but I'm still going to talk about what exactly we're doing. So let's go ahead and start by looking at the note in 3D. So you can see that left and right to this note is on the x-axis, and forward and back are on the z-axis. So if you kind of think about it like this, on the x-axis we want the note to kind of turn left and right, and then on the z-axis we want the note to kind of flip back and forth like that. So in our script, the first thing we're going to do is the z-axis. So we're going to say if our note hand, if its rotation in the x, and we're going to lerp over its rotation in the x. So our first argument, I guess we can start with the x. I think I said z, but we'll start with the x. So we'll start with the x-axis, and this is going to lerp between the input direction in the x times the note sway amount, and then that is going to be weighted by 10 times delta, because delta is a very small number. And this should be input underscore dir instead of input dot dir, just like that. And we're just going to copy this line for line, and we are going to change the x for a z. So input direction, and then the big kicker here is that this input direction is not of z, it is of y. Because remember, our input direction is a vector 2, and that represents the player's movement on the keyboard. So left and right handle our x movement, forward and backward handle our quote-unquote y movement in two dimensions. However, in 3D space, our player is going to be moving forward and back on the z, left and right on the x. Once again, always a major confusion and a place for bugs, but we need to bring it up. So let's go ahead and run the game and see if we have any tilt and sway. So I'll come over here to my run note. If I back up, you can see it turns left and right, forward and backwards. And if I move left and right, it pushes forward and back. So that's backwards. We want to change that. We want our x rotation to handle the input direction of the y, and we want our z rotation to have the input direction of our x. All right, so that's just a simple mistake. So if we go over to our run and we click on our run, if we move to the left, you'll see the note moves to the left. We move to the right, you'll see the note moves to the right. We move forward and the note tilts forward, and we move backward and the note tilts backwards. So that looks pretty good. Now that our note moves left and right, let's add the final addition to our note system, and that is adding text. And the way we're going to do this is we are going to use a GUI, and we are going to do some overlays. So let's go ahead and go back to our player. We already have our GUI node set up, and we already have a layer for our reticles. So we are just going to create a new canvas layer for our overlay. So just go ahead and hit Control A and add a new canvas layer. Let's go ahead and add a control node. this control node is going to be our note overlay. We want this control node to take up the entire screen. So let's go ahead and set it to full rect. And then we also want to make sure the transform is the full size of the screen. So in this case, my game's 1920 by 1080. Now we want to go ahead and add a color rect. So go ahead and say color rect. We want to change its color to be black. Let's open up our layout panel and we are going to define where it is. So right now it's up in the top left. We want this to be roughly half the size of the screen. So we need to set its size to be 960, which is half of 1920. And we need to set its Y to be 1080 because we want it to be the full height of the screen. And then position-wise, we need to make sure we set this to be 960, so that way it's on the right half. So we pushed it 960 pixels to the right. So if you go ahead and run the game, it's obviously going to be displaying. But if we grab our run, you can see that we will have our note on the left and a black box for our text on the right. Now we need to do two things. The first thing we need to do is we need to add a little bit of alpha to this, so that way the player can see the environment behind the text a little bit. And we also want it to kind of fade in. We don't want a hard black line right in the middle of the screen. So let's go ahead and rename this to black overlay. Let's go ahead and look at the material. Let's create a new shader material because we can't do a single tutorial without a shader. We're going to create a new shader. In the shaders folder, we are going to go ahead and call this one the note _ fade shader because we want to fade our note in the center of the screen, and go ahead and open it up. And just like all the other shaders, I will leave them in a pinned comment or the description down below. So go ahead and copy in your fragment shader into the shader here and save. So you'll see right here, the entire black screen goes away, but you'll also notice that we have some shader parameters that we need to modify down here. So the first thing is that the rectangular width is going to be 960 pixels. So you can see right there, and we even have a little bit of a fade. So the next one is how many pixels wide is the fade going to be? I don't think 100 is really enough. I think 240 is a lot better because it kind of expands it out a little bit more. And of course, the fade strength you can see really just affects the opacity here. I want it dark, so I want it somewhere around 0.7, but that should still be enough for the player to see. So let's go ahead and test. So you can see that, and if you imagine I have a note in my hand, I can still see the enemy over there. Maybe if I have too much text on the screen, you wouldn't be able to see it, but it does allow the player to still kind of get a hold of their environment. All right, so the next thing we need to do is we need to add another control node. So under the note overlay, add a control node, and we are going to call this one, actually let's just leave it as control for now. We want this to kind of be on the right side of the screen, right? So let's go ahead and go into our transform properties. And if I just kind of drag this up to like 700, that's a good width, I think. And then if I set the, 1100, no, that's a little too much. We want it to be a little bit less than the screen like that. Yeah. So if you see there, what I'm building out here is essentially what size I want the text box to be. And now I just need to move it over to the right side of the screen. And I think 1200, yeah, that's probably a good number. Now I want some padding. I don't want it to be touching the bottom, and I don't want it to be right at the top. So I'm just going to give it like 20 pixels or so right there. So now we have a kind of text box, but we actually need a text node. So we're going to add a rich text label, and we're going to call this our note content. And so now you can see here, if I type test text that I am writing for the tutorial, you'll see that only test appears, and you'll see that it has a little scroll bar right there. So we need to make sure that this fills the entire screen with the text we have. The best way to do that is just to turn on fit content on and set scroll active to off, and that'll get rid of that little bar. We probably want our words to be centered. Then go ahead and come down to your layout here. In fact, what we should do is set this to take up the full width of the control. So you can see that size is defined by our control node above. So this will be centered here. And this will make more sense if I turn this off. It'll go up to the top. And you can kind of mess around with these settings to see what you like. I like center. I think that looks the best, especially if you have a lot of content. But the big thing is, instead of doing a full rect, I think we actually want to do H center wide. All right, so now that we have some text, I'll go ahead and run the game. And you can imagine that if we have a note and we pick it up, we want this overlay to appear to the player with the text. So let's do a couple things. The first thing we need to do is we actually need to access our note overlay as a unique name, as well as our note content, so that way we can change these in code. And we want our canvas layer to be turned off, so that way we can't see anything. So go ahead and disable the note overlay for now, because when we pick up a note, we want to turn it on. And of course, this is an interaction, so this is all going to be defined in our interaction controller. So we need a few new variables. We are going to need our note overlay. We are going to need our note content, and then we need a new variable that I'm going to call is note overlay display. This is a Boolean, and by default it's false, and that's just going to keep track of whether or not the note overlay is visible. Back down here in our input function, where we check if we've just clicked, we want to do two things. We want to set our note overlay dot visible equal to false, and we want to set our is note overlay display equal to false. And the reason for this is when we are putting the note away, so we want to turn off overlay, so that way it's no longer on the screen. Then, of course, down here, when we collect the note, we have just picked up a note. So the next thing we want to do is set note overlay dot visible equal to true. And we want to say is note overlay display equal to true. And we want to go ahead and take our is note overlay, and we want to check if that overlay is displayed up here. And the reason for that is we don't want to bother trying to get all the children of the note hand or do any of this logic unless we actually have a note picked up. So remember, this logic is if we have already had a note in our hand and we're trying to put it away. And this note is the logic if we are just picking up a note for the first time. So now let's go ahead and run the game and test and see what happens. So running the game, I'll go over to my run. If I click on it, you'll see the overlay pops up. You will see the text on screen. The note is still moving around as I move. And if I left click to close the note, it is gone. So now the final piece to this puzzle is being able to define what text is going to be displayed on the screen. And for that, we are going to add another variable to our interaction component that can be exported and modified. So let's go ahead and do an @export var. This is going to just be called content, and this is just a type of string. And this is going to hold whatever you want to write on screen. So for the run note, let's go ahead and look at the interaction component. You can see content now appears, and I just want to say run with an exclamation point on it. So if I go to our interaction controller and go down to where we do the overlay, all we need to do is get the interaction component from the note, and then we need to set its content. So we're going to get a variable I'm going to call IC, which is short for interaction component. And this is just equal to note, get node or null. And the node we're getting is our interaction component. And once we have our interaction component, all we need to say is our note content, which remember is where are we? This node here, this rich text. So note content dot text is equal to the interaction component's newly created content variable. So now if I run the game and I come over to our note and I click it, you'll see it now says run. If I go into my note and I say run with 2 exclamation points, click the note, run, and run. So that looks pretty good. So now we're actually going to run into a slight problem, and that is with the text note. So as you can imagine, this text note has a lot of information on it. It also has new lines, it also has spaces. Mine doesn't, but yours might have tab indents, and we can't really handle that with just a simple string right off the bat. So just to show you this, I'm just going to paste in the text for that and run the game. And you'll see that if I come over to this note and collect it, you'll see that it kind of just balls together in a big old thing, and it isn't formatted properly, or at least it doesn't look like it does on this note. And you'll notice that all of those slash ends appear in the text itself, when those should represent a new line. So if I go ahead and hit escape, we need to add one little bit of logic to our interaction component, and that'll be down here. In our ready function, if we have an interaction type that is a note, we need to do this one line. And this one line is content.replace, and it's going to replace /n with /n. Or sorry, it's going to replace /n with /n. It's a little out of there. Make sure you put a colon there. It's a little out there. But essentially what we're doing is we need to format our text so that way it shows up properly. And we want to do this on ready because we want to do it the first thing that happens when this loads into the game. However, this will not do. These little /n's are referred to as BB codes, and that essentially just allows you to format text using hidden characters called escape characters. So /n is the same as essentially pressing enter. It's a new line character. So by default, our note content, which is our rich text label, doesn't have this enabled by default. So before we set the text, we need to say note content dot bb code enabled equals true. So now, if you remember, our text note has all those /n's, and I'm just now realizing that we didn't actually replace the content. We need to say content equals content.replace. We need to have that assignment operator. So let's go ahead and run it and see what happens now. So let's walk over to the note, grab it, and as you can see, we now have the text written on the right. So that way, if you were to go into the dark, your player could still see it. Or if you just wanted to help people who didn't have to squint on the left side of their screen, there you have it. And there you have it. We now have a note and diary system that is very immersive for our controller. There is one bug that we need to fix in our interaction controller. If we scroll up to our input method, instead of saying is action pressed, we want to say is the action just pressed. Otherwise, you'd be able to pick up the note and it would immediately go away. You closed it. So let's go ahead and run. If I come over here, I'll give a click down on my note. I'll let go and it's still fine. And I have to left click again to get rid of it. I'll go ahead and click on the run. You'll see that pops up as well. And I left click again. So now we have an interactive and immersive note system in our game. As a reminder, all of the code for this project is on GitHub, so if you have had any issues or anything isn't working as expected, feel free to pull the GitHub project and compare your work against it and see if there's any differences. And if you have any ideas or recommendations how this system could improve, please leave them in a comment down below, and I will see you all in the next video.